enough of me. Tonight we have Steve Westgarth, friend who I met on the conference circuit, really, the mobile conference circuit, but today he's talking about everyone's favourite subject and least discussed and least debated, entity framework. So Steve, hand it over to you.
Very much. Hi everyone, thank you very much for inviting me along tonight. As Wieran said, my name's Steve. I'm a software developer, as I guess most of you in the room are. Primarily a mobile software developer, so I don't know why I'm here talking about .NET. That seems a bit unusual. But for the last probably 6 years, I've been running a company called Footsqueak. Footsqueak essentially started as a mobile app development studio. I was fortunate enough to sell it last year, and as part of that, I've moved to another company called Polymorphic, where I'm essentially heading up the .NET team, working with a whole bunch of .NET developers, and trying to get them to develop good software. Which is something that I think everybody would aspire to do, and sometimes we achieve and sometimes we don't quite seem to achieve. And this talk is really inspired out of a journey that I've been on over the last year, the things that I've never really thought about before, because in my previous career everything's already been done. And it's opened up some really interesting questions that I've never really had to answer before, so I thought it was quite interesting to me and maybe will be interesting to some other people too. So let's start right at the beginning. I've been coding for a long time and actually was brought up, initially when I was doing my A-levels I learned classic ESP. I'm sure there's some people in the room started out with those sorts of things. I then progressed on to ASP.NET Web Forms, and we all had a lot of major issues with web forms as a whole. There was this undefined application architecture, separation of concerns, which we'll talk a little bit about later on. It was always aspired to, but you could never really get it right, I didn't feel, in say, web forms. You had complex web pages, huge performance issues, and one of the big bugbears for me was that there was very little abstraction, and there was very little control over the HTML. Limited support for testing, you couldn't really do test-driven development, and there was lack of reusability and minimal parallel development could go on. We were using source control at the time. It was very difficult to sort of get multiple developers onto the same thing. And then on the 13th of March 2009, it was a great day for developers. That was me on that day, because that was the day that suddenly we received .NET MVC 1.0. And that felt phenomenal. We suddenly had this concept where you could clearly separate out the different layers of your architecture into your model, your view, and your controller. Now, I was working at the University of Chester at the time, and we were kind of making it up as we went along. It was an academic environment, and we were developing software, we were making applications for people. All was good. But what we found, I'm sure it's something that a lot of people found, is that MVC didn't really stand for MVC. It actually stood for Massive View Controller, because essentially anything that you ever wanted to do was always put into the controller. So at that point, we started playing and seeing how we could improve upon things. Now, why am I telling you all of this? It's because when I joined Polymorph, probably July last year, I joined this .NET development team, and I thought we'd left a lot of this stuff behind, a lot of the problems that we had. Because lots of people have come up with design patterns they like to use, lots of agencies have made you do things their way. But I arrived at Polymorph and found that actually nobody had done that. Nobody had thought about how we should build software. What they'd done is they'd say to developers, build that application, and they'd go away and build it. So if an application came in and Tim was working on it, then Tim would build it his way. And if an application came along and John was working on it, John would build it his way. But if John ever looked at Tim's code, he wouldn't have a clue what was going on, and vice versa. So it opened up all sorts of problems. And that in itself had a huge number of major issues. There were limited coding standards. There was no agreed best practice. The idea of unit testing wasn't really talked about. We had this view controller bloat. Everything was difficult to debug, very difficult to maintain things. Working together was challenging. Code was slow and unresponsive. So, in the interests of trying to help us to improve, we wanted to get from the monkey at the left to Homer on the right. We started looking at how we are actually developing software, and we started talking around the fact that the company as a whole needed a design pattern. So as we started talking around the fact we needed a design pattern, it started talking about all sorts of questions for us. because there are many, many design patterns out there. There are many, many ways that you can develop software and different ways you might want to do it. But we wanted to start with a solid foundation. We'll talk about the solid principles in a little bit. But we really wanted to start with a solid foundation. We wanted to talk about how we could actually build the best design pattern we possibly could. And we didn't want to take something which was just off the shelf. We wanted to make sure we examined it, looked at it, and saw how we could really improve it and make it as good as we possibly can for us. And the starting point for me was the fact that at Polymorph they had this habit of putting the entity model into the main project. And that caused us all sorts of problems as you started having merge conflicts, as things didn't really work the way you wanted it to. Developers were extending entity framework left, right and centre, and it wasn't doing what you wanted it to do. And really what we really wanted to do was to see how we could separate concerns properly so that we had different things in the places that they should be, where it made logical sense for those things to be. So we started off by making a very simple change. And the simple change we said was that we're going to extend the entity model. We're going to have the DAL in a separate project. We're going to have the entity model over here a little bit, and we're going to have everything else, the presentation layer, over at the side. And that opened up some good opportunities for us. So it allowed us to create some improvements. First of all, we said that all of our views were going to have strongly typed models. It allowed us to start introducing some static helper methods, transforming model objects between the DAL and the main presentation layer. We could start to really annotate models correctly. We insisted that every project had a base controller, and we agreed a folder structure, and also made sure that we were doing dependency injection correctly. So what I want to do is just take you into one of those early projects and show you some of the things that we did, because there's some interesting things which sort of sit around that. So if this all works, let's open up. So you can see what we've done. We've obviously split our DAL, which everybody would typically have done. I imagine most of you would do in your projects. We've introduced this idea of a base controller. We're going to talk a little bit about the customer controller. That's what I've based this presentation on, so we'll go into that in a little bit more detail in a few minutes. But essentially we said that everything that was data related was going to sit in the DAL, and if we wanted to extend the DAL, we were allowed to. And everything within here had to have a strongly typed model. So you had to have everything relying on customer model. Now that opened up some interesting challenges, because developers were used to doing everything in the controller, and that took me back to how things used to be when I started out developing. And you had this idea that people were doing select lists, where they were doing db.customers, .select new model customer, and then selecting everything within the controller, and that was causing me some personal issues that I didn't particularly like. But we'll look at sort of how we did that in 1 second. So we looked at introducing this idea of a model extensions folder. So what we essentially created was a number of static model extensions. So if I just go into my model for a second, we had this idea that you would have a customer model. Customer model would have a number of attributes. You'd have customer ID, first name, surname, address 1, address 2, address 3, address 4, postcode, etc. And we'd have within our model extensions, it will be a static class. We would pass in the customer itself as a view model, and we would pass back the customer model. So this customer is the entity coming directly from the DAL, and obviously customer model is an instance of the model that I just showed you. And then within this, what you'd be able to do is simply say return new customer model, and you would say customer ID equals view model dot customer ID, and then you'd obviously have your first name. View model dot first name.
Could you look at anything like Automapper to?
You probably could, absolutely, and we've looked at those sorts of things, and yeah, absolutely, that would work absolutely fine. So we obviously set it up in that particular way, but essentially we would have in this instance, you would have an extension method for every one of your entities that would sit. So now within my customer controller, I should have the ability to, there we go. So it essentially converts directly into your view model. Now that became in itself, that was very useful for us. It opened up a whole raft of possibilities, which again just tried to remove code from within the controller. And we liked that as a team. We thought that actually the less code that we have in the controller, the better it is for all of us. We also liked the idea of basing everything on our own base controller. It allowed us to set up the fact that we were pulling in our DB entities, our new design pattern entities from the DAL, and making that available to all of our controllers without having to do any further work. So that started to work quite well, and that started to get developers to do things in the way that we wanted them to do it. But there was so much more that we could do, and we started looking around on the internet to find how else we could do things, what else we might be able to introduce that would actually help us. And what we kept coming across time and time again was this idea of the unit of work design pattern. And when we started looking at unit of work, the other thing that came out quite heavily was this idea of a repository pattern and what a repository pattern might be able to do for us. Now, we had some issues with the repository pattern, and our thoughts were that didn't sit well with the solid principles. And again, we're going to talk about the solid principles in a few minutes' time. But before we get onto that, let's just talk about what the purpose is of a repository pattern. So, first of all, it's good for testing. If you don't rely purely on entity framework, it becomes quite simple to start introducing some unit tests and to start testing each individual class, each individual method. And if you pass everything into a repository pattern, that becomes quite straightforward. It also allows for loose coupling. So it means that actually, if there was a brand new version of Entity Framework tomorrow, we could replace Entity Framework entirely with a new version, and we'd have minimal effort to do. The application wouldn't have to change very much in order to upgrade to a new framework version. It allows us to easily extend database functionality. It's a clean architecture, totally independent of frameworks, and it gives us the ability to add and remove some features and abilities of Entity Framework. So, for example, in one of our applications we were working on, it was very important that we didn't delete anything from the database. So because we were depending on our own repository pattern, we could simply remove the delete methods and make them not available in the presentation layer. So therefore developers couldn't accidentally make that available. Obviously they could do a bit of work and do it, but it still made it unlikely to happen. So in essence, our repository pattern, which I'm going to show you in a second, looked a little bit like this. We had the controllers, and every controller would link to a specific repository. Every repository would have its own DB context that it would be relying upon, and that would serve back to the controller. Now that was fine in small applications that didn't have many transactions going on, but it does cause us a lot of problems because every DB context kept track of its own in-memory set of changes. So that means that if you were starting to add something into this repository, and you then added something to this repository, until you'd saved off this repository wouldn't know anything about it. So if you think about a typical ordering application, where you've placed an order and you've also added lines to the order, if that was done in two separate repositories, you can see a situation where one wouldn't know about the other and you would start to have an inconsistent database, which would cause some problems. So as we looked at that, we really saw that what we needed a unit of work, and that's where this talk essentially came from, because that was the route we initially went down. We started looking at creating a pure unit of work design pattern. So going back to this, we still had our model view controller, our presentation layer, and we decided that we were going to, at this stage, put all of our units of work into our DAL, into our data access layer. So let's just take a little look at how that worked. So we've still got at the bottom here, this is our, what was our DAL, it's now been called entity model, but doesn't make too much difference. And you've just got a standard entity framework. We're not really interested in country. Customer is the only thing that's particularly important within this. So what we then did was we created a generic repository. So that generic repository essentially relied on an entity which was passed into the generic repository. We then set up, so we had a get method, and we added various filters onto that, so you could order, you could sort, you could do whereby, and those sorts of things. We did a get by ID method, we did an insert method, we did a delete method. And then we, once we had that repository in place, what we then did was we created a unit of work class, and we essentially set up a repository for each of our entities. So we had a customer repository, in this case. If I wanted to have a country repository, then essentially I would have to copy and paste that entire bit of code there, and I would need to set up another repository, which might be called if you had country. So because we were basing it on a generic repository, it meant that every time we added a new table or added new things into our framework, it became fairly straightforward to start extending that, adding new repositories into it, and making those available to our controller. And the way that becomes available to the controller, within customers controller up here, you would simply instantiate unit of work, instantiate new unit of work, and in your index you get access to, in this case, underscore UOW dot. I can access country repository, I can access customer repository, but the great power of doing something this way is that all changes that are made to the unit of work are kept in memory until you call unitofwork.save, which is one of the methods we implemented in the generic repository. So that means that if I started adding something to my order, and also started adding something to my countries table, they wouldn't be saved off, so there'd be no database inconsistencies in actually the unit of work would deal with that. Now, as we did some reading around that, a lot of people were saying, well, isn't that just a bit like having a DB context within your entity framework, because you've effectively got, you're almost kind of repeating the DB context layer. And I can take the point, but what it does do is it gives you the possibility of controlling what's happening within that DB context, of doing some full unit testing around that, and actually making sure you're getting the right thing back. What you might have, in fact, I think I've got on one of my slides, you might have something which looks like this. So what you can effectively do is create a mock unit of work and mock repositories, which you can then pass into a test class, which makes that very testable. And that for us, or certainly for me, seems to be a very good thing for us to be doing, because ultimately we want these developers to be moving more towards test-driven development and more towards maintainable code, that they actually understand what's going on. Whereas I think if you just grab the DB context, it doesn't necessarily do that. We can still extend the DAL if we want to. So if I just jump back to the other project for 1 second, we still said to developers they were allowed to do things like this. So if we go into our DAL and into extensions, at the DAL level, we still allowed them to, for example, say public string full name get first name plus this dot surname. Surname, there we go. We still allowed them to do things like that. And suddenly that became available to us in our unit of work repository, and became really easy to separate out and pass backwards and forwards from the DAL into the main into the main presentation layer. But we still didn't think we got it right. So we were happy that the unit of work was starting to do what we needed it to do, but we still felt there were issues. And our issues came down to this: the solid principles. So, has anyone come across the solid principles before? Everyone's heard the solid principles? Fantastic. So when you think about the solid principles, just to go through them very quickly as you know what they are, the idea of single responsibility, the idea that a class should be open for extension but closed for modification. This Liskov substitution principle, so that we can easily substitute classes of subtype S without altering any of the desirable properties of T and those sorts of things. Interface segregation, no client should be forced to depend on other methods that it does not use. Dependency inversion, high-level modules should not depend on low-level modules, both should depend on abstractions. So as we started looking around the unit of work design pattern, what we realised is that actually unit of work doesn't do any of this very well. It violates a number of things. So nominal abstraction, it's still very closely coupled with entity framework. You can see that because the entity itself is still seen in the presentation layer. If you removed entity framework from unit of work, it wouldn't work. You wouldn't be able to just replace entity framework with another framework version. So actually the problem we were trying to solve initially wasn't actually solved. We liked the pattern, but it didn't work. The DB context entity makes it all the way into the application layer. It violates the single responsibility principle. And that's debatable because it depends how your unit of work class is constructed. But you've still got multiple responsibilities within that class, which causes you some issues. We also didn't like the fact you had these opaque dependencies, because all dependencies were hard-coded into this unit of work class, so it wasn't extendable, it wasn't easy to maintain. And we've already talked about violating the open and closed principle. So we started talking about how could we improve this? How could we make things work a little bit better for us? How could we get to a design pattern that was actually going to be more solid, but was still going to give us the advantages that we felt cognitive work was starting to give us? So this is what we started talking around. We started saying, actually, we need to totally decouple our DAL from our model view control, from our presentation layer. What we need to do is we need to introduce a new layer, a new business logic layer. And if we introduce a new business logic layer, what we need to do is to pass everything from the top of the project all the way through the layers to the bottom of the project, but at no stage should something in the presentation layer depend on something that's all the way up in the DAL. And actually, even if you're in the business logic layer, there should be nothing in the presentation layer which depends on that DAL. You should be able to replace anything that you want to replace to make things easier. So we came up with some key principles, and these key principles were what sort of guided us as we started to look at how we could improve our solution. So we said the data is going to be transferred in each layer into a specific layer model, or a layer-specific model. We liked the idea of a generic repository, but we also wanted to be able to extend it for individual models, so minimizing code duplication. We wanted business logic to be totally divorced from the application layer, no database logic operations performed in the controller or application classes. And the idea of that was to essentially minimize view controller bloat, making code much more readable, and also encouraging adherence to agreed coding standards. So that was our starting point. That was our overarching guiding principles. So we've got a business logic layer. We've got a design pattern sample project. That's the main presentation layer. We've also got our entity model. So within our entity model, as we had before, we've still got our entity framework. There's nothing else currently within this. We've talked around whether or not we should allow developers to extend within the DAL or not. Our current preference is that they don't, that everything is done within the business logic layer. We're open to discussions as to whether or not that should be changed or not. But that's I guess a different conversation. So within our business logic layer, we agreed a structure. And the structure we came up with was we'd have, first of all, a repositories folder, and the repositories folder would essentially contain our generic repository. So that's essentially the same generic repository as we had in Unit of Work, but we'll come back to that in 1 second. We would then have a models folder, and that was going to have specific models that were specific to the business logic layer, and weren't going to be used by the presentation layer or by the entity framework. You'd also have an entity extensions folder, and that was essentially going to do our static extensions that we did before. We were going to use helper methods in the same way as we used in the previous project. We've also got a logic folder, and I'll talk about in a second about what we did with logic and how that worked. So let's just take a look at what is now in our generic repository for a second. So it's set up in exactly the same way as our previous project was. The problem we've now got is, though, that in order to use this generic repository, if we're going to pass in an entity from our DB context, it needs to be transformed at some point in this repository into a model that can be readable by the business logic layer. So we need to consider how we're going to do that. And we also wanted to do it the generic way, so we were minimizing code duplication, so we had the minimum amount of work we needed to do in order to set up our project now repository. So let's just go down to get by ID. So when we get by ID, what we've done is we've set up an entity extension. So it's a static extension helper method, which now exists within the entity extensions folder. What we've done, we've created a generic entity extension method. So into this, we're going to pass an entity and also a model. So it could be a customs model, a country model, or whatever, the entity being customers, country, or whatever you actually wanted to work with. Now, within here, we've still got this business of actually transforming our entity from one into the other. So if, for example, it's a type of customer model, then we will do obviously the customer thing. If we scroll down a little bit, it was type of country. We do our country thing. Totally accept there are ways to potentially automate that sort of flow, and again, that's something we will probably look to introduce. But what that does mean is that we can start to do some actual logic within here. So if we wanted to extend, for example, to say, I don't know, say we had a property of, trivial example, full name, we can start to put that sort of logic into here, and we can start to say, entity conversion, first name plus full plus surname. Or you can get more advanced than that. We started the particular project we were working on that was relevant to that. We needed things like age, days since, and these sorts of things. And you can start to introduce that sort of logic into that place. Again, passing away from this particular class. So we wouldn't actually do the work in here. That would violate some of the solid principles. But we could do some of that base setup that previously we'd done by extending our DAL by doing it directly in this space here, which we felt worked for us. And if I just go back to generic for a second. So we pass in the two model, we pass in T entity, we return val, so that the return value that we've passed in. So then that means when we go back to our unit of work class, what we do is we set it up, and we took the decision that actually we didn't want to have the repositories actually declared directly within this class. We wanted to separate them out. Now that's not entirely in conformance with the solid principle of extending rather than modification, but we felt it was more in keeping if we had a base class that was set up that we didn't change, and then we created specific classes that we could actually use so partial classes that would depend on unit of work, to implement things like customer and other things. And also within here, within that customer's class, it also allows us to extend that customer's class to introduce other methods. So you say you want to add extra things to the repository and those sorts of things, we can provide those things back to our presentation layer. So if I just go back to our application layer for a second. So we've still said we're dependent upon a base controller, and that's still where we're setting up what we're still calling unit of work. We've still got our customer's controller. And we're still operating on the same pattern where we say unit of work, customer repository, get by ID, and then converting it to view model. But crucially, what we're actually doing here doesn't depend at all on the entity framework. So if we remove entity framework out of the equation, and entity framework no longer exists in the project, it wouldn't make any difference to us. None of the models, none of these conversions at all depend in any way on that higher level conversion. And also, obviously, as we talked about before, that became very unit testable. It became easier for us to start, making sure there wasn't any view controller bloat, to really understand what's going on in the controller, to make sure that it wasn't affecting anything within the project. And also in our tests, if I just run this for a second, let's see why I've broken something. Because full name doesn't exist. Don't get rid of that. We found that this became very, very responsive. So as we started implementing applications using this sort of structure, we found there was no delays. It was a really quick framework to use. Things became very, very responsive, and it worked. And it was something that actually our developers found very simple to get their head around. They could see very clearly what was going on in the different layers. We could split our responsibilities of who was going to do what, where they were going to work, and how they were going to work. See if that actually loads up. Yes, it does. And yeah, it worked really well for us. Now, we've since looked at different ways of extending this further, and we've got this idea of creating business logic classes. Business logic classes are where we start to put some of the actual main grunt work that happens within our application. But again, it's totally abstracted out, so it's not dependent upon entity framework, it's not dependent upon the presentation layer in any way. And it means that as we're looking within our Scrum team, if we're giving different responsibilities for different things, people can actually focus on what they want to do, and it doesn't really matter whatever anybody else is doing, because everything does have every class has its own responsibility, it's all in its own defined place, which again seems to work well for everybody. So let's just look at the key advantages of some of those things. So it's totally decoupled from entity framework. Makes it possible to easily adhere to the single responsibility principle. It does adhere to the substitution principle, which we quite like. It gives us total interface segregation, and we've also made sure that we've got dependency inversion throughout the project. And as we've said, Entity Framework could entirely be replaced. The only problem we really have with it is that it doesn't adhere entirely to the open close principle. The repositories are still hard-coded within the unit of work class. We do extend unit of work as a series of partial classes, but as I'm sure you can appreciate, it's not a true implementation of the principle, and somewhere that potentially we want to look to improve it going forward and see what we can do. So, what's the reason for bringing this to the front and talking about it? First of all, it's something that I guess doesn't get talked about very often. I think who works in an agency out of interest? Anybody work in an agency? Anybody who, obviously you're all software developers. Who has an agreed design pattern in their place of work? That's interesting. See, I was actually expecting every hand in the room to go up. Because for me, when I got to Polymorphic, I was shocked that we didn't have an agreed design pattern. So in that case, actually, it makes this conclusion quite valid. So do you have an agreed design pattern in your place of work? And if you do, when did you last challenge the accepted norm? And I guess if you haven't got an agreed design pattern, is it something that maybe you should be considering doing? Because actually, by putting something like that in place, the big advantage it's given us as a company is that if I now look at Tim's code, in theory, it should conform to the same design pattern as the project I've been working on, which makes it much easier for him to pick up and maintain my code, and vice versa. It also gives you a reason to start thinking about how you can better adhere to the solid principles. I'm not claiming that what I've shown you tonight is perfect by any means. It's not. But what it has done is it's started a conversation in our office about how can we make things better and how can we become better programmers, and I think that's really important. If you do use unit of work, consider that actually there are better implementations and things you can do better with it. It's Microsoft recommended. If you do a Google search for the implementation of it, Microsoft have some fantastic knowledge base articles on why you should be using unit of work and how to implement it. But actually, I think some of their work can be improved and can be enhanced and explored. And if you've never heard of unit of work and have never explored it, then it does have a lot of merits if you extend it and do other things with it. So I would consider having looked at it and seeing what you could do. Thank you very much for listening to me ramble for tonight. If you are interested in exploring any of that code that I very badly tried to code on the fly there, I have put it on the GitHub so you can have a play around with it. You can see how we've implemented some repositories and those sorts of things. I'm also on Twitter at Steve Westgarth, so please feel free to find me there. And the other important thing to mention is I also organise this, which is Code Mobile. Code Mobile is primarily a mobile developer conference which takes place in Chester. It happens between the 2nd and the 5th of April 2018, which is just after Easter. So you've got Easter Monday, we start on the Tuesday morning. So it's Tuesday, Wednesday, Thursday. Once for 3 days. We've got some fantastic speakers, including some people from Capital One. Wieren's apparently going to rock on up and do some agile stuff for us, which will be very cool. Supposedly. It'll be wonderful. And if you're coming from .NET Not, if you use the code .NET Not on the website, we'll give you 25% discount to say thank you for coming to .NET Not, and that's all good. So thank you very much for your time tonight. I hope that was useful. Please feel free to come and talk to me at the end and see if we can talk about design patterns in better ways and help each other to improve our code. Thanks very much. Any questions?
You're going to tweet the slides, I guess. Link to the slides.
I will link to the slides. I'll put them up on something. I'll tweet that. Slideshare or something. Yes.
So, unit of work, is that like a transaction in SQL?
Yes. So essentially, you've got your database up here. So your database is doing all of your interfacing with your SQL database. So if you forgot Entity Framework for a second, and you said what we're going to do is we're going to have stored procedures. That's how we're going to do ADO.NET stored procedures. Unit of work sits between the database and the application itself. So you have this repository pattern, if you like, and the main reason for implementing it is to make sure that your entities don't go out of sync. So you would want DB context and Entity Framework handles this very well, but if you were using stored procedures, you would have this problem. If you added a record to customer and you also added a record to orders, then unless you saved both, or even if you did save both at the same time, you could have database inconsistencies. Whereas what unit of work allows you to do is to save them all into the same bucket, the same unit of work, and when you press save, it gives the database an opportunity to make sure it's handled any inconsistency and make sure that's all dealt with. Cool. Any other questions? No? Okay, thank you very much.